We are rocking through this. So we are now going to look at hypothesis tests for the population mean. We worked through what it was for the proportion. Now we're going to see how it is affected with the mean. All right. Right off the bat, you see that we have the criteria up front, and it's a little bit different before we jump into our steps. Okay. So to test hypothesis regarding the population mean, use the following steps, provided that we have a simple random sampling or randomized experiment. You have no outliers and the population from the sample is normally distributed or the sample size is big. The sampling values are independent of each other, so the same situation applies there, right? My sample is less than 5% of my population. Same deal. All right. Then we jump into our hypothesis test. So notice this is the mean. So we're looking at mu, right? So I'm going to make this bigger. Same criteria applies. My mean is equal to whatever I'm starting with, that initial value. If it's two-tailed, means that it changes. That's the does not equal. Left-tailed is less than. Right-tailed is greater than. Exact same criteria that we started with in 10.1. Still carrying through, right? And the same thing we worked with the proportion. Again, I'm going to scoot this up a little bit. You will select a level of significance depending on the seriousness of making a type 1 error. Same thing. Step 2 for the mean and the proportion are the same. I'll make that bigger. Again, we are not going to take the classical approach. So that is all the way gone. Not the classical approach. And does this look familiar? Yeah, that's our student T distribution, right? Students T distribution with our degrees of freedom. Again, we're not going to worry about this table to approximate a p-value because here's the thing. Your table can't even give you an actual p-value. So you have to use technology, which we are, of course, going to use StatCrunch to pull that off. And then look at step 4. So we're not going to do this part. We are doing the p-value approach, but we're going to use StatCrunch and look at this. Oh my, same thing. That's the other reason why we really like the p-value approach. That makes it nice because no matter what, the p-value is going to be less than your alpha you reject. Whether you're talking about a proportion, whether you're talking about a mean. We don't do standard deviation, but that's another hypothesis test that you can do. Same concept applies. Exact same concept. Then, guess what? We're going to state the conclusion. Is there sufficient information? Da 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 da. Sweet, right? So regardless of whether or not you're using the mean or the proportion, the key to this is if you're given mean information, you're using mean variables. We will use StatCrunch, p-value criteria is the same, and we'll state the conclusion. Cool, right? Then let's rock through some examples.